Are you guys around? Can you hear me? Ritisha, you're able to hear me?
Yes, I can hear you.
Okay, cool. No, I didn't hear any response from any of you, so I thought maybe my audio was bad. All right. You heard all that I said, right, guys?
Yes, sir.
Okay, cool. So we have two homeworks to discuss. I think we discussed question 1 from the last class. I remember from the homework 1. So we should start with homework 1, question 2. If only I can bring it up in a second. Is that? Okay, all right. I think we discussed that Bernardo is splitting into 2 different cases and doing a weighted probability. Can someone confirm? Arav, you remember, right? 1/3 into some branch and 2/3 into another branch using symmetry. All of that, you're okay on that one? Okay. So I think we should start with question 2. Oh, am I sharing screen? No, not yet, right? All right. Okay, finally we are settled. Okay, so question 2. A, B, C are 3 random independently selected with replacement. So with replacement means you put it back and then pick it again, right? So there's a chance that A and B are the same also, and C is also the same. So you understand with replacement. Essentially, with replacement makes things independent, right? You put it back, so essentially independent draw. So what is the probability that ABC plus AB plus A is divisible by 3? Okay, so let me just randomly ask someone. Keshav, did you get an answer on this one?
I didn't finish my working for this one.
Okay, Anika, how about you?
Yes, sir.
What did you end up getting?
I got 11/27.
11/27. Okay, any other answers, guys? So slightly less than half. Okay.
So I got 13/27.
Yeah,
Good.
even I got 13/27.
13/27. Okay, all right. So let's discuss. So who was 13/27? Dipra, and I heard one other voice. Who was the other one?
No, Ritisha.
Ritisha. Okay. Okay. What is the probability that this quantity? So this quantity I can take A common outside. So it's A into BC plus B plus 1 is divisible by 3. So clearly we can divide into 2 parts, right? So A is divisible by 3. So 0 mod A, or A is not divisible by 3, right? A is not divisible by 3. So non-zero mod A. Sorry, mod 3. Mod 3. Okay. So A is 0 mod 3, or A is non-zero mod. Non-zero means leaves a remainder other than 0, which is 1 or 2. Okay. So clearly, in this case, you don't really care about what B and C are. With 1/3 probability, A will be divisible by 3 because 2010 is a multiple of 3. You can clearly see that 2010 is a multiple of 3, right? So since you have a uniform distribution of numbers leaving a remainder of either 0 or 1 or 2, with 1/3 chance, A will be perfectly divisible by 3. So 1/3 into don't care on B and C, which is 1. And then if A is not divisible by 3, this branch is 2/3. So 2/3 into, if A is not divisible by 3, then we definitely want BC plus B plus 1 should be divisible by 3. Okay, so we can divide into a few cases, right? So B, let's say B is here, and then let's say C is here. And then let's say we have reminders of 0, 1, or 2 possible. So 0, 1, or 2 possible. Okay. So for each of these 9 cases, we can quickly, each of these 9 cases is equally likely, right? Because I'm just talking about B and C. Okay. Now, so we'll evaluate this quantity BC plus B plus 1. What is the remainder of that, right? So if B and C are both 0 and 0, the remainder is 0 plus 1, which is 1. So if B is 0, so let me finish this row first. If B is 0, then the remainder is just 1, 1, 1, right? And if B is 1, then it is what? So if B is 1, it is C plus 2. C plus 1 plus 1, which is C plus 2. So in this case, it will be 2. And then C plus 1 would be 1 plus 2 here, which is 3. But 3 is effectively same as 0. Remainder of 3 means remainder of 0. And then if C is 2, so 2 plus 2 is 4. 4 is effectively 1. And similarly, in the last row, if B is 2, then what do I have? I have B is C plus 3. So effectively 2C, right? I can ignore the 3 completely. Okay, so 2C will leave a remainder of 0. 2C will be 2 here. 2C would be 4, which is effectively 1. Okay, so there are only 2 of the 9 cases, namely this guy and this guy, where it's perfectly divisible, right? So what goes in here is 2 of those 9 cases. Okay, so what is this? So 1/3 plus 4 by 27. So this is, yeah, 13 by 27 indeed. So Anika, maybe you can check your silly mistake. Maybe you did a small one. Unless you're already spotted it.
By 2 by 3, 4 by 27 into 2 by 3, because A is not divisible by 3 by with probability 2 by 3. So that also has to be taken into account.
Correct. Yeah. So those are the 2 branches, right? A is divisible by 3, in which case I don't even care about B and C. A is not divisible by 3, in which case I completely rely on this combination to be divisible by 3. Right? So A is not divisible by 3 with a probability 2/3. And in that branch, depending on how B and C turn out to be, as we just saw, of the 9 possibilities, equally likely, 9th of them were. That makes sense, Anika? Everyone good? Keshav, you're okay? Rahil, question? Yeah.
So why won't we consider B and C values greater than 2?
Sorry, I didn't understand.
So what if B and C are greater than 2? Why don't we consider that?
Greater than 2. No, when I say B and C are 0, 1, and 2, I mean the remainder when it's divided by B. Of course, B and C can be all the way till 2010. But it's a symmetric distribution of divided by 3, right? So effectively, 7, 8, 9. So all of these rows are like 1, 2, and 0, 1, 2, and 0, 1, 2, and 0.
Okay, so it's B mod 3 basically.
Everything is divided by 3, right? Yeah,
Okay.
correct. Yeah, B mod 3, correct. Yeah. So what I exactly, you're right. When I say B, it's actually when you divide by 3, what is it? When you divide by 3, what is the remainder? Yeah. Okay, so obviously, otherwise it's impossible to multiply by such big numbers and finish it off in quick time. Okay, makes sense, right? All of you. Any other doubts, guys? Okay, so what I'll do is I'll pause after every question in case someone has a doubt, they can still ask. Okay, the next one. Rahil, did you get something on this one? On this circle?
Yes, I got this.
What did you get?
But D.
D, 9 pi by 2.
Yeah.
Anyone else agree or disagree with him?
Even I got this. So.
With him, same.
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 Okay, all right, cool. So let's still, for completeness, let's just do it still. So I'll just draw one big circle. And then there's a line here. Okay, and then there are 2 circles here, right? I'll just draw a circle here. And then there's another circle here. So the center for the main one is here. Okay, it's an easy question only, but just for completeness, I'm just doing it. If I use the auto to draw the circle, it's just I'm not able to place it in the center, which is why I have to hand draw it. Okay, anyway, so if I count all the measurements from the bottom, so let's say this is the level 0, okay, and then let's say the green circle's radius is capital R, why even capital R? Let's keep A and B, that's easier, right? So let's say this is radius is A, and let's say the small circle's radius is B, then the radius of the big circle, the radius of the big circle will be how much? A plus B, I guess, right? Because the diameter is 2A plus 2B. Okay, so which is A plus B. A plus B becomes the radius. So the big circle center would be here. Okay, so this is the height. So this is at the green circle's level. This is at the big circle's center. And then, okay, all right. So now I can draw a perpendicular here. And I can connect this with this. And just simple Pythagoras theorem should do it, right? So this height, so this would be how much? 2A. So this height is at 2A, right? Because it's a diameter of the green circle. So it's 2A minus A plus B, just A minus B. So this height is A minus B. And this radius is A plus B. And then this is given to be, length of PQ is given to be 6 units. So this is 6. So this is P and this is Q. Sorry, PQ is 6, right? So this
It
is
will be 3, sir.
3. Yeah, 3. Sorry, my bad. So this is 3. Okay, now just Pythagoras theorem should A plus B whole square minus A minus B whole square is 3 square. And then that's your 2AB minus 2AB. So 4AB is 9. And then what do we want? We want the area of the shaded region. Okay, so shaded region is what? The big circle, pi into A plus B whole square minus the small circle minus the medium circle. So that will leave only a 2AB here. Pi into A square and B square will get cancelled. Pi into 2AB. So I have my AB as 9 by 4. So it's 9 by 4 into pi into 2, which is 9 pi by 2 indeed. Okay, easy question, right?
So can you just say have you got A minus B as the height?
Oh, sure. Okay, so I'll erase all of these. Okay, let me count all my lengths from the bottom. Okay, so this is at 0 level. Okay, now the green circle's center is at a height of A. You agree?
Yeah.
Right, and the green circle's diameter, the top portion is at a height of 2A. These three are clear. 0, A, and 2A. These are clear, right?
Yeah.
Now, the big circle, the red circle, the center for that is at A plus B, because we know the radius of the big circle is A plus B. Are you with me?
Yeah.
Okay, and therefore this gap is just 2A minus A plus B,
Okay.
which is A
Good.
minus B. So that's how you got A minus B. Yeah, probably that's the main critical step here, right? And figuring out that you have a Pythagoras theorem here. Okay, question 3 was that. Question 4. I still see a few videos off, guys. Please turn on the videos. Siddharth, did you do this one? Question 4?
Yes, sir. I
Okay,
got D 108.
108. Anyone else with the same answer?
Same.
Same answer.
Okay, Manan, how about you?
So I got 72 for this one.
72. Okay, are you able to turn on your video, Manan?
So it's on.
Oh, somehow I can see everyone else. I cannot see you.
Oh, wait, I'll try.
Okay, fine. 1 to 9 says that the product is in 2 different ways, 6 different integers from 1 to 9, such that the product is a perfect square. Okay, let the squares be P square and Q square, where P and Q are both positive. What is P plus Q? Okay, so let's write out the numbers. 1, 2, 3, 4 is this. 5 is just 5. 6 is 2 into 3. 7 is just 7. 8 is this. 9 is 3 square. Okay, and then that's it, right? 1 to 9 included. Now, the product is a perfect square, right? So clearly, 5 cannot be in that 6. because 5 does not have a Jodi, right? So 5 cannot be in that 6.
Even
Numbers two.
7.
Exactly. Yeah. Okay. And 7 is also prime. 7 also cannot be. So 2 numbers are ruled out. So we can only accommodate the rest. And then it has to be a perfect square, right? So 1 is safe because 1 itself, it's not going to bother anyone because it's a perfect square. 2 is also safe. Okay. And 3 square is also safe. 9 is also safe. Now, the remaining numbers are 2, 3, and then 2 times 3, and then 2 cube. Okay, so of these remaining 4, how many should we choose? So we have to choose 3 of them because we've eliminated 2 numbers. Of the 9 numbers, we have eliminated 2 numbers, right? Let me just put them in a different color. I've eliminated 5 completely. I've eliminated 7 completely, right? So I have to eliminate one more number such that I have pairs, right? So I have, what do I have? I have 2, 3. I have 2 times 3, and then I have 2 cubed. So just simple experimentation will tell you, if I leave out this 2, am I okay? I have 1, 3 and another 3. I have 2 power 4. I'm okay. So I'm okay with leaving out this 2. And then what else am I okay with leaving out? If I leave out this 3, then it's a problem, right? Because, sorry, the last one is 2 cube. I cannot leave out the 3. That's a problem. If I leave out this 3, then the other 3 does not have a does not have a Jodi. So I must have, for the same logic, I cannot leave out this guy also. So the only other one I can leave out is this guy. Okay, I can leave out this, in which case these 3 will be a perfect square. Just like these 3 is a perfect square. So this is what? This is a square of what number? 3 into 2 square.
12.
Square. Yeah. So 3 into 2 square ka square. And whereas this combination is which one? It's 2 into 3 uska square. Okay. So now others are fine, right? So the definite guys are this guy, and this guy. So that's another 1 into 2 into 3. So 1 into 2 into 3 is definitely there. In addition, we have, so which is 6. So in addition, we have an additional 6 or an additional 12. Okay, so it's effectively, we want P plus Q, right? So P and Q are either 6 into 6. This is the common 6, 1 into 2 into 3. And the other one, these are the additional ones. So 6 into 6 and 6 into 12. So 6 into 18, which is 108 indeed. Does it make sense? Whoever got 72, were you able to find your mistake?
So yeah, so I didn't do the last part with 6 and the 7.
Okay, but it clearly says there are 2 different ways of combining them, right? Which means you should have wondered, I only found one way. Where is the other way?
Yes.
Yeah. Okay. Next one. Soham, what did you get on question 5?
So I missed last class. I have my exams going on.
Okay. No problem. Arav, were you able to do this one?
1 second. Yeah, I got C.
C. Okay. Anyone else agree or disagree with him?
I agree. See.
C as well.
Yeah,
Okay.
even I got
I agree.
Okay, I see a few other nods as well. Okay, so let's anyway do it. So he wants Q, X, and V to be on a straight line, right? So which means the slope of QX, just 1 second. Never know. Yeah, sorry. So the slope of QX should match. I'm still sharing my screen, right? Okay, good. So the slope of QX must match the slope of QV. In this case, is it drawn well? QV is this, right? Okay, here. Okay, all right. Let me just first draw this one. Okay. So what is the slope of QX? So this height is how much? It's just figuring out all the heights properly. This is D. Therefore, this is D minus A. And this is how much? B minus A. B minus C. So this is B minus C. So Actually, it's a negative slope, but I don't, I'll just look at rise over run. As long as it's in the same direction, it's fine. So D minus A by B minus C, technically with the negative sign, but I'm just,
Height would just be A, right?
which one? Say that again.
Height is just A, right? It's written.
Oh, you're right. I made a mistake. This is A. You're right. This is D minus A. Yeah. So A over B minus C. Correct. So, and that should match this quantity, this upon this. Okay. So this should match D upon P. Oh, as simple as that. Huh? Okay. So AB equal to BD minus CD. So let's write AB plus CD equal to BD. Since he has everything as equal to 1, that's a hint that I have to divide throughout by BD. And then it becomes A by D plus C by B equal to 1. Yes, indeed. Yeah. Okay, cool. Again, another straightforward question, but maybe it looks daunting, right? The main thing is they scare you with like seemingly difficult questions with 28 different things labeled, and all the choices are also a little mind-boggling, right? So the immediate tendency is to skip. But if you look at it for just 30 seconds, it's actually a very easy question, right? So on the other hand, there might be a single one-line question, which might be extremely hard. Yeah, go ahead.
You could also have done this using similarity. I think that would be like one step.
Okay, go ahead, please. Anika, which is similar to which?
So you do, I think, VSX and VPQ, because then, so then you get D minus A over D equals C by B.
So
And then,
VSX and XTQ, is it?
no, VPQ, the,
VPQ, the big one. Yeah. VSX and VPQ are similar. Yeah, which is another way to say VSX and XTQ are also similar. But yes, and this will also give you a ratio, right?
yeah, and but that would be one
Okay.
step.
How will it be? Can you just take me through? What did you do? VSX by what about
D
what?
minus A over D equals C over B.
C over B, I heard on the right side. What did you say? D minus A by?
By D, that D.
D. Okay. And then still you still have to cross multiply, no? Or
So then minus A over D equals C by B.
oh, okay. You just said 1 minus A by D equal to C by B. Okay. All right. Yeah. Cool. A by D plus C by B equal to 1. Same result. Yes. Nice one. That was question 5. Question 6. Moksh, what did you get on question 6?
Which question could you like show the actual
Yeah,
question
yeah.
itself?
Yeah, it's semicircle, this one.
Let me just check. Question 6, I got A.
A. Okay. Dipra, do you agree with him?
Yeah.
Okay. Keshav, same?
A only.
Okay, A only, right? Semicircle intersects the hypotenuse of the triangle. What is the shaded area? Okay, so let's label some of these. I'll call this as A. This is B. This is C. This is D. This is E. I generally find this method convenient. If you're able to visualize better, that's great. Okay, so what do we want? I generally, in all of these overlapping area, one thing that's worked well for me is, what is my goal? My goal is A plus B plus C. Okay, my goal is to find A plus B plus C. Now, and then next step, I'll write down what all I know. Okay, so I know. So what all I know, I'll write it down, right? So obviously I know A plus C plus D, because that's one semicircle. I also know the other semicircle, which is B plus C plus E. I know that as well. Okay, and then in this case, I can angle in a semicircle is 90 degree, right? So it makes sense for me to connect this with this. If I connect this, I'll label all the points so that it's easy. So I'll just call these points as A, B, C, and this is D, right? So ADB is 90. You guys know that angle in a semicircle is 90, right? Because this This is 180. Therefore, by the half angle relation, the angle here would be 90. So this is 90. This is also 90. Okay. So yeah. And then you also know the area of the triangle ABD. Therefore, ABD triangle area. So maybe I can split this as C1 and C2. Sorry. I'll just call this as, maybe I'm making it overcomplicated than it's needed. So I'll just call this as C1 and C2. So this portion I'll call C1 and this is C2. Okay. So I'll just mention here, I want this, and then I know C1 plus C2 plus D, right? Which is one semicircle. The other semicircle is C1 plus C2 plus E. Okay. I also know the two triangle areas. How do I know the two triangle areas? Because it's I know this is a semicircle of radius 3. So this is 6 and this is 8. The entire thing is 10. And then you know that the lengths will be proportional, right? So the lengths will be proportional. So I know the triangle of ADB. So I know C1 plus D. I also know C2 plus E. Okay, in fact, I know them individually, but looking at it now, I won't even need that, looks like. So I can generate this quantity. How do I generate this quantity? I can, let me just label them as like 1, 2, 3, 4 or something. Okay, so this is 1, this is 2, this is 3, and this is 4. So I need A plus B somehow. So clearly I should do 1 plus 2. And then let me assess what do I have and what don't I want and all that. So 1 plus 2 will give me A plus B. It will give me 2 times C1 and 2 times C2. By only I want 1 C1 and 1 C2. And it will give me a D and a E, which I don't want. So I can just subtract 3 and 4 together. I think that should do it, right? So it's 1 plus 2 minus 3 plus 4. Okay, and rest is just simplification, right? So this is one semicircle, which is pi into 3 square by 2. The other one is the other semicircle, which is pi into 4 square. Radius is 3, right? Radius is 3. Yeah, pi into 4 square by 2. And then these two can be combined, right? I didn't even have to split them as two different triangles. So in retrospect, I didn't need this middle wala line. But anyway, if it's needed, you can still find it. Okay, I'll just maybe take a minute to explain that. And then this is the triangle area, right? Which is the half into 6 into 8, which is 24. So clearly the minus 24 is in order by subtracting the triangle. So this is the 24. And then 1 plus 2 will give me pi into 3 square plus 4 square. So pi into 25 by 2 indeed. Okay, sounds good. Okay, although in this case, in this question, it was not needed. Suppose I'm just saying, suppose you needed the area of the triangle ADB, you can still do it, right? ADB, because I know the lengths of AB and CB as 6 and 8. And by proportion, I can find AD also. So for example, AD, the length AD, I'll erase this. The length AD will be 6 into 6 by 10. Do you agree? Because all the three triangles here, one sec, I'll just draw a new picture. Nothing to do with this question. In general, with right angle triangle, you should know this main property. So I have okay. So let's say this is, I have a perpendicular from the right angle here. Whenever I have a perpendicular from the right angle, it splits the right angle into 3 similar triangles. So let's say this. Yeah.
I think you're slightly overcomplicating it.
Oh, what is overcomplicated?
Like, you can just tell that if you add up the two semicircles and then subtract the area of the whole triangle ABC, you get the shaded area.
Yeah, correct. I agree. So for this problem, it was an excess. And in fact, we need not even have calculated the individual ones, which I didn't. I just clubbed them together. So we are done with this question. I agree. We didn't need to go so elaborate. But there could be cases where the shadings are a little weird, where you have to actually, right? For example, let's see. So for example, suppose in this question itself, want to find just C1. Just C1 alone. Okay. How would you do it? So suppose I can have another diagram where this part is drawn and my shaded region is just this pink region alone. Okay. Can you guys find the shaded region? Okay, just find the pink region, nothing else. Just the pink region alone.
It won't be an exact answer, but you can use trigonometry.
No, you don't need trigonometry. You can find an exact answer for just the shaded region. Sorry, 1 second. This is C1 plus D. No, I stand corrected. No, we won't be able to find this exactly. Yeah, I agree. I agree with you. Okay, yes. So for this problem, we are done. I just wanted to understand. I just want to illustrate one other important thing, right? So if I have a right angle triangle ABC, and if I have a perpendicular here, okay, so this splits into 3 similar triangles. So this was 6 and 8 in this case, right? 6 and 8, and AC of course was 10. I can find other measurements like AD and CD and BD just by similarity of triangles. The 3 triangles here, the original big triangle and the little triangle and the medium triangle are all similar. We can see that by AAA property very easily. Okay, so this portion AD therefore becomes, the 6 acts as the hypotenuse, 6 into 6/10. And then BD would be 6 acts as the hypotenuse, and BD is the middle length, right? So it's 6 into 8/10. Similarly, for this triangle BDC, the 8 is the hypotenuse and this is the longer side. So it's 8/10, right? It's a 6, 8, 10 Pythagoras theorem. Therefore, it's 8/10 is the ratio of the medium side to the hypotenuse. And there's another way to look at this is 8 into 6/10. Both are same. My point is you can find the altitude as well as AD and CD in case it comes in handy somewhere else. But yes, back to this question, Moksha, I agree with you that finding that pink portion alone is, I don't think you'll be able to do it. I agree. Okay. Question 7. Question 7. I roll 2 dice. At least one of the scores is 3. What is the probability that both of the scores on the dice are 3? Okay. Manan, what did you get on this one?
So I got 1/6.
1/6. Okay. Ritisha?
1/6.
That's 1/6 as well. Okay. Any other answers?
So I got 111.
So I got
then
111.
So it's
111.
1/6.
Okay. So between 1/6 and 1/11th, okay, people are divided. Okay.
It's
all right,
conditional probability, right?
Yeah. I
Yeah.
roll 2 dice. At least one of the scores obtained is 3. So this is a known fact. So this is known. One of the scores obtained is 3. What is the probability that both of the scores are 3? Okay. So essentially, what if I have to list out the sample space? So it's 3, 1, 3, 2, 3, 3, or all the way till 3, 6, right? In between. Okay. And then the other possibilities are 3 here. So 1, 3, 2, 3, all the way till 6, 3. So in total, how many of them are there? There are 11 of them because 3, 3 is a repeat. I cannot count them twice. So there are 6 of them here. There are 6 of them here, but I scratch off the 3, 3 because it appears twice. I scratch off. So there are 11 outcomes that are possible. That's what you know at the end of this sentence. At least one of the scores is 3, means of the 36, you know that 11 of them happened. With that extra information, as someone rightly said, conditional probability, what is the probability that both of them are 3? So it's 1 out of those 11. So it's 1 out of 11 indeed. Yeah. Whoever got 1/6, please check. Right? Or do you want to share what mistake you did? Whoever got 1/6?
So I didn't cancel out 3.
You didn't cancel out 3. But then you should have got
Yeah.
1/12 in that case, not 1/11, not 1/6.
No, sir, I didn't cancel out 3 and 3 and I took it twice. So it became
Oh,
2 by
okay. I see. So it's 2/12. Okay, all right.
Yeah, I think I did the same thing.
Okay. Question 8. Alvita is planting blah blah blah. Identical square paving stones laid out in a rectangle measuring x by 1. She finds that when she adds a border of width 1 stone, the area of the border is equal to original area of the patio. Okay. How many possible values for x? Yeah, Rahul, what did you get on this one?
I got C.
C. Okay. Keshav?
Yeah, C4.
Okay, 4. Any other answers, guys? Okay. All right. So this is a rectangle, and then you have a uniform garden around this. Okay. Sorry, it's not so uniform. My garden. That's fine. When she adds a border of 1, how many possible values for x? What is x? Measuring x stones by y stones. So this is x and this is y. He hasn't given that anything is bigger than the other, right? So x and y, I'll just mark x and y the same color. And then this uniform width is 1 everywhere of 1 stone, right? All of these stones are like 1 by 1 like this, right? So this would be x plus 2, and this will be y plus 2. And then this area is matching the area in the center, right? So the area is matching. So x plus 2 into y plus 2 is matching the area in the center, which means this will be 2 times xy, right? So 2 times xy. Only then it will match the area. It's fairly easy, right? So xy plus 2x plus 2y plus 4 equal to 2xy. So, and then a standard way to solve some of these problems is get everything to one side and factorize. So I'll move everything to the right side. Xy minus 2x minus 2y, okay, and equal to 4. I'll retain it here, okay, on the left hand side. So 4 equals, so this is where I can factorize, right? I want my xy, so I'll put a x here, I'll put a y here, and then I want a minus 2x, therefore I'll put a minus 2 here. I want a minus 2y, therefore I'll put a minus 2 here. Okay, so essentially I've added plus 4, which is not given to me. Therefore, I'll compensate by adding a plus 4 here. Okay, so which means x minus 2 times y minus 2 is 8. Okay, and now there are 4 possibilities, right? So it can be 1-8 combination or 2-4 combination or 4-2 combination or 8-1 combination. So there are 4, and it doesn't say x is the smaller one or y is the bigger one. It just says x by y. How many possible values for x are there? So the 4, you don't have to figure out and waste time what those x and y values are, but you know there are 4 of them. Okay, so the key step is factorization. For example, in another case, suppose you have an expression which is xy minus 3x plus 4y, right, equal to blah, blah, blah. Okay, let's say equal to, what shall I say? But that doesn't matter, right? Whatever it is, or does it matter? What is it? Okay, I'm just randomly putting something. I'll change it later. So how do I manipulate it? So I will say xy minus 3x plus 4y, right? So I'll put a x here, I'll put a y here. That satisfies my xy. I'll need a minus 3x. So I'll put a minus 3 here so that can combine with the x, so minus 3x. And I need a plus 4y, so I'll put a 4 here. But I've introduced a minus 12 here in the right-hand side. Therefore, I'll compensate by putting a minus 12 here as well. So it's a product of 2 quantities, which gives 84. And now I can go on from here, right? Or however number of combinations there are, I can figure out based on number of factors for 84. How much is that? 6 into 14, which is 2 square into 3 into 7. Therefore, 3 into 2 into 2, 18 factors. And based on that, you can solve anything else, whatever you want. Yeah, but the idea is factorization like this. Okay, all of you good on this one? Question 8. Question 9. Question 9. Question 9 also is another simple one, right? Siddharth, what did you get on question 9?
Actually, I couldn't solve question 9. Like I was confused in that.
Okay. Anika, what did you get? Question 9.
I got 1/2b.
1/2. Yeah, it seems like a fairly straightforward question, no? The diagram, a semicircle of radius, semicircle of diameter 4, from which a smaller semicircle is reduced. The two semicircles touch at exactly 3 points. So this is, if I draw angle in a semicircle is 90. If I just draw an isosceles right triangle here, that's it. The matter is done over already. So this is 2. So this is 2 and this is 2. The radius is 2, right? So all of this is 2 and 2. So this height would be isosceles right triangle, right? So 2 upon √2, which is √2. So radius of the smaller semicircle is √2. Radius of the bigger semicircle is 2. So the scale factor is 1:√2. This is the scale factor. And he wants to compare ratio of areas. The ratio of areas is scale factor square. So it's 1:2. Very simple question, right? Does it make sense? Dipra,
Yeah.
same answer?
Got it.
Yeah, same answer. B.
Yeah, sorry, someone was saying something.
No, I said I understood.
Understood. Okay. 9. Question 10. Rahil, what did you get on question 10?
The E.
E, 60 seconds.
I got 40.
40. Okay. Arav, what about you?
I got
6,
40, but I wasn't sure.
60, 40. Any other answers so far?
I got E, sir. 60.
60.
Even I
Okay.
got 6.
Yeah.
Okay, multiple 60s. Okay, Thomas runs at constant speed, both running and walking. So running is R, walking is W. And then a downward escalator is moving. So escalator gain will say E. Okay. Thomas can run down in 15 seconds when an escalator is moving, right? So moving escalator, his speed becomes with R plus E, he's able to travel in 15 seconds, correct? This is speed and this is time. Okay, and with R plus W, which is, sorry, and he can walk down in 30 seconds, right? So he's going with the escalator. With W plus E, he can travel in with a smaller, which is a smaller speed, therefore longer time. One day when the escalator was broken, which means the E is not there, it took 20 seconds for him to run down. So his just running was 20. And then how long would Thomas take to walk down the broken? So what does W correspond to? That's the question, right? So yeah, so the distance, so we can just say effectively the speed is, so let's say the distance is always the same D, right? So D, and D, right? So in fact, I can keep the distance as 1. Does not even matter, right? So in other words, my R plus E is 1/15. My W plus E is 1/30. This is 1/20, right? And I want W. So how can I generate W from all of these 3? I can just do some simple manipulation. I can do R plus E minus W plus E. That will eliminate the E. Okay. So that'll give me R plus W. And then I can subtract R. That'll give my W. Right. So just manipulating what I have, right? So R plus E is 1/15. W plus E is 1/30.
So this will give you minus W.
Oh, yeah, you're right. It'll give
You
me
have to do
minus
W plus E minus R plus E plus R.
Understood. But anyway, I'll realize the silly mistake when I get a negative answer. So fine, let me just continue here. But yes, you're right. So this will give me minus W. So this is 60, common denominator, 4 minus 2 minus 3. So as expected, minus 1/60. Okay. So yes, W is 60. I mean, W corresponds to 60 rather, right? W is 1/60. Therefore, it'll take 1/60. Did you guys find your mistake? Whoever got 40, did you find your mistake?
Yes, sir.
Okay. Two parabolas. Moksh, what did you get on this one? The parabolas probability.
31.36.
Which one? Say that again.
D for donkey.
D for donkey. 31 upon 36. Soham, you said you didn't have time to do it. Rahil, what did you get?
Same D.
Same. Dipra?
Yeah, D only.
Okay. Two parabolas chosen independently by all of these values are chosen independently. What is the probability that parabolas will have at least one intersection point? So if I set the two equations to be equal, x square plus ax plus b equal to x square plus cx plus d, and then I just manipulate, I get a minus c into x equal to d minus b. So x is d minus b upon a minus c. Okay, what is the probability that parabolas will have at least one point in common? Okay, so if so I can just, if a is not equal to c, right, and a equal to c. If a is not equal to c, then surely there's an intersection point, right? The denominator is not 0. Whatever d and b be, I don't care. It may be 0, it may not be 0, I don't care. So all d and b okay with me, right? So if a is not equal to c, then I don't care about d and b at all. So what is the probability that a and c will not be equal? A can be any value with one probability, and c should not be that particular value. So with a 5/6 probability, a will not be equal to c, in which case I'm okay accepting any d and any b. Okay, and if a equal to c, what is the probability for this to happen? It's 1/6, because c has to be that particular value that a is, in which case if the denominator is 0, then I have to, so if the denominator is 0, a is same as c, which means what? So just for example, 2x plus b equal to 2x plus d, right? So which is why I get the 0 in the denominator, right? For this to happen, my b and d must match. Only then I can have, in this fractional form, it will seem like 0 by 0. But if you resort back to writing in this way, so let's say a and c were 2 each. So 2x plus b must match 2x plus d, which means b must match d. So b is okay, b can be anything, but d must be in compliance with that. So with 1/6 probability. So this is my a, this is my c, this is my b, and this is my d. Right? So which is 5/6 plus 1/36, which is 31/36 indeed. Okay. Did you guys do some other way? Moksh, same approach, or did you do something different?
Same approach.
Same, right? Anyone else has another way to share? Anika, what did you do?
So I did the same thing.
Same. Okay, cool.
I did it just by find the probability that they don't have any point in common, just and doing 1 minus.
Okay. And that came out to be 5/36, is it?
Yeah, so then I did 1 minus 5/36.
Okay, last question on this one. Each vertex of a convex polygon. Dipra, what did you get on this one?
I got C.
3120. Okay. Manan?
So even I got C.
C.
So I got B.
B. Okay. I always like when there are two answers so that the discussion becomes fruitful. Okay, cool. Any other answers? 6 colors to choose from, and the ends of diagonals have Moksh, what did you get? Keshav, what did you get?
C.
Didn't get this question, so sorry.
Okay. Cool. No problem. A, B, C, D, E. He has labeled them as A, B, C, D, E rather than saying just any convex polygon, in which case it becomes a little difficult. If he didn't label, then the question comes, do I treat each vertex as same or what? Different. In this case, he has given specific names, which is good. Right, let's draw a polygon, pentagon, sorry. Convex polygon. Yeah, pentagon. Oh, say hexagon, sorry. A convex polygon, A, B, C, D, E, no. Pentagon, what am I talking? 1, 2, it doesn't have to be regular or anything, doesn't matter. So, okay, he might have as well said convex pentagon. I don't know why he said convex polygon. Fine. And then, so this is A, B, C, D, E. And then he has to color it with, there are 6 colors to choose from. And the ends of the diagonal must have different colors. Ends of each diagonal must have a different. How many different colorings are possible? Okay, so there are, let's say there are 6 colors here in our kitty. I'll just call them with small letters. So P, Q, R, S, T, U. These are our 6 colors, or 1, 2, 3, 4, 5, 6, whatever. Okay. Now, how many colorings are possible? So let's start with the simplest case. Let's say I consume all the 5 colors, which means different colors for each of them. So that'll be A can take any of the 6 colors. I can go in order and say any of the 5 colors B can take, any of the 4, and so on, right? So that's for case 1, when I'm using all 5 colors. 5 colors. Okay. Now, if I'm using 4 colors, that means what? Obviously, 2 adjacent vertices should have 1 color. Okay. And then the rest 4 are 4 different colors. Let's randomly pick something. Let's say I'm assigning color P to the adjacent vertices C and T. Okay. And then I'm giving the other colors Q, R, and S to the other 3 vertices. Okay, this will be a situation, right? With 4 colors, that's what will happen. 2 adjacent vertices will have the same color. Okay, now you have to be careful. Let's go step by step. Let's just visualize, right? So the first choice would be, which is that edge which will be the special one where both the vertices will have that same color. There are 5 edges to choose from. Like A, B, B, C, C, D, D, E, and E. So which is the edge which will have the same color on both the endpoints? So that's 5 choices. Having done that, which is the chosen color? In this case, in fact, let me not put P. I can intentionally put something. Let's say put S. So which is the chosen color from the 6 that you have in your choice to assign to that edge, that special edge, which will have the same color on both endpoints? I have 6 choices. So having done that, I've assigned that color to that special edge, and then I can go in either clockwise or anti-clockwise order, choosing the other colors, right? So it doesn't matter. So let's say I go in clockwise order, counting from one of them, right? So there'll be 5 choices for B. So let's say I'm going this way, or anti-clockwise. Let's say I'm starting from one of them, and then I'm going leftwards, anti-clockwise. So 5 choices for B, 4 choices for A, and then 3 choices left for E. So I cover from here to here, and I'm done. Okay. So that is with 4 colors. And let's try with 3 colors. So with 3 colors, how will the configuration come? So let me just erase this. So with 3 colors, A, B, C, D, E. Okay, so let's say I give a color P here. So I want to be frugal with colors. So I want to give the same P here. I don't want to use up the color P because they're adjacent, right? They can afford to be the same color. Now for C, it cannot be same as P because there'll be a diagonal AC. Therefore, I have to choose another color. Let's say Q, or let me not say Q. Let me just say R. Okay, doesn't matter. And then I can be frugal again with D. I'll just choose the same R. So for now, we are okay, right? We are able to accommodate with just 2 colors so far. But E will definitely need another color because E is going to have a diagonal both from P as well as from C. So it can neither be P nor be R. It has to be another color like T or something. Okay.
What do they mean exactly when they say ends of each diagonal must have different colors?
Meaning, so if I have a diagonal which is AC, A and C must have different colors.
Oh, okay.
Yeah. So there are how many diagonals in a pentagon? N into n minus 3 by 2, right? There are 5 diagonals, right? N into n minus 3 by 2 is 5 diagonals. All of those 5 diagonals the endpoints of each diagonal must have different colors. Yeah, you're okay. Okay, now what did I do now? So my configuration with 3 colors will turn out to be that I have 2 pairs of consecutive edges, which are all of the same color, which are of PP, RR, right? And then there's one unique node, one unique vertex, which will have the 3rd color. So let me start from the unique person. Okay, so I'll start again. Just visualize and just go through the process. You'll figure out for yourself. My first choice would be, which is the unique vertex? In my example, it's E, right? It could be any one of the 5 vertices, right? Having chosen that, what is the color you want to give to that unique vertex? Of the 6 colors I have, I can pick any one. So that's 6. Now, starting from E, start traveling, let's say clockwise. You want to give the next 2 as the same color, right? So you have 5 choices to pick, and that's the color you're going to give to the next 2 adjacent ones. So 5 into 1, because 5 into 1 meaning you have 5 choices to say what color D gets, but the same color you have to repeat here. So no choice left for when you come to C. And then when you travel further, you come to B. I have 4 choices, and that same color you're going to repeat for A as well. Right? I'm writing the 1 and 1 just to be explicit. Okay, I'll pause here for now. After this is just factoring out and getting an answer. Is this clear to everyone or any doubt? All of you okay on this? Okay, cool. Now I can obviously don't multiply each of them. That's stupidity. Like look for whatever common. So 6 is common, 5 is common, 4 is common. I can grab a 6, 5, 4 at least from each of them. 6, 5, and 4. So 6, 5, 4, and then what else is balanced? I have 6 here. I have a 15 here. I have a how much? 5 here. Right? So how much is this? 30, 120. 120 into 26. Okay, so does it match? 12 6 are 72, 7 carry, 12 2s are 24. Yeah, 3120 indeed. Yeah, makes sense. Whoever did not get this, is it, again, there could be other ways of solving. Okay, Dipra, did you do something different or same?
No, same way.
Same. Okay, Soham, please try these questions. I know you didn't have time this week. Go ahead. Rahil, how about you? Same method? I cannot hear you, Rahil.
Yes, a similar way.
Similar. Okay. Manan, yeah.
So I did a different method. I got the same answer, but I didn't understand how you got the 5 at the beginning of 4 colors and 3 colors.
Okay, I'll repeat the how I got the 5, right? For the 4 colors and 3 colors. So when I'm using 4 colors, okay, I'll just draw a picture again. Okay, so when I'm using 4 colors means what? So I want to start with 4 colors. I'll assign some color here, P. Okay. Some other color Q, some other color R, some other color S here. Now, when it comes to the 5th one, I've consumed 4 colors. I have to choose one of the colors which will not violate. So let's say I can use S here because I have a neighbor here. I can afford to have the same color as the neighbor. Yeah. Do you agree that the configuration will look something like this? Okay.
Yes.
Having done this, now, how do we come up with a general arrangement for this? So there is a special edge where both vertices of that edge, not diagonal, edge.
Yeah.
Right? Where both edges have that same color, right? Which is that edge? There are 5 edges possible. I can choose which of those, which is that edge. Is it AB or is it BC or is it CD or blah, blah, blah. There are five choices, right? That's the first 5. After that, we got everything, right? And then start with what color to give to this special edge. I have 6 choices.
Got it, sir. Got it, sir. That I got.
Yeah. Okay. And for 3 colors, same thing, right? For 3 colors, what did I do? So I have to be frugal. Of course, I didn't cover this point. I cannot do with 2 colors at all. Even with 3, I just barely managed. that came through as discussing for. Okay, so with three colors, so I want to be tight with my colors. So I'll repeat. Initially, I want to be as frugal as possible. So P and P. Now, when it comes to this edge, I have to choose another color because there'll be a diagonal going from here to here. So I have to use a different color, Q. Here I can afford to keep the same color. So far it's tight. I've kept as minimal as possible. Now, when it comes to this last edge, it must be some other color, right? It cannot be the ones I've used because this has a diagonal running up here as well as here. So I have to choose a third color for sure. Okay, so you agree on this configuration so far, Manan?
Yeah, so yeah, this
Okay.
this part.
And then you didn't understand how the 5 came from in this one, right?
Yeah, so that I got because it's 5 edges you multiply by 5. That I understood.
No, the 5 is coming, that was the previous one for the 4 colors. For the 3 colors, which is the special vertex, which has that third color. So you have P and P repeating, Q and Q repeating, R is the unique. So I'll find the
Got it.
unique one. In this case, a unique vertex. In the previous one, it was a unique edge. In this case, it was a
Yes.
unique vertex. So 5 choices for identifying which is that unique edge. Yeah, makes sense?
Yeah, so that makes sense. Got it. So
Okay.
thank you.
Cool, no problem. Okay, so we're just done with this question, right? Let's stop here and then we can start with the second question set next week. I'll give one more set for this week. Okay. Overall, I think,
So,
yeah, go ahead, Moksh.
one question. Since it's taking like whole classes to get through each question sheet, is it possible that you can just upload the answers for each question sheet in addition to explaining them in class? So if we want, we can check our question sheets ourselves.
Okay, I'll upload the answer sheet, but let me do that. I don't want to do beginning of the, otherwise people will look at it and then be biased and then they'll try to tweak
Could you
around.
do it like, for example, last week's question sheet, could you upload the answer sheet today? Or this week's question sheet, you upload it next week?
Okay, all right, I'll do that. I can do that.
Cool. Thanks.
Okay, sure. Thank you.